Class, today in this video we will be talking about the end behavior of polynomial functions. So what does that mean? Well, the end behavior is talking about these ends, as in when x approaches positive infinity, what's happening to f of x? F of x is actually going to positive infinity also for this polynomial function. And as x approaches negative infinity, what's happening to f of x? Well, as x approaches negative infinity, f of x is also approaching positive infinity, as it did when x was approaching positive infinity. Okay, well, how do we determine this? We obviously see from a graph that this is so, but let's say we're not given a graph. What if we're just given the function? Well, you look at the leading term. In this case, the leading term, which is associated with the term with the highest exponent, would be 5x to the fourth. You want to look at your coefficient, in particular the sign of your coefficient, whether it's positive or negative. Here we have a positive 5, and you want to look at your exponent, whether your exponent is odd or even. In this case, it's even. That means when it's even, ultimately, both directions, both ends will be having the same behavior. When it opens up, in the case of, as in when you have a positive coefficient and your exponent is even, then this graph will be opening up. You'll be going to positive infinity. What happens, say, when you have a negative coefficient next to your leading term? Well, the graph flips. You're going down, opening down in both instances because you have an even exponent. You'll also notice that you might have some turning points here, and in this case you can have as many as 5 when the exponent is 6. 6 minus 1 is 5. So the number of turning points is 1 less than your degree. You'll notice it's having the same behavior. In this case, it's going to negative infinity on both ends. The same behavior because it's an even exponent. What happens when you have odd exponents? Well, you have opposite behavior. You can think of this sort of like your x cubed is your sort of base case. If you want a tangible and easily to recall function. So when you have x cubed, as x approaches negative infinity, f of x also approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. So you're doing different things at different directions, as opposed to the case when you had an even exponent. So here, so you look at the leading term, you have an odd exponent, you have a positive coefficient. So that means positive x, positive f, negative x, negative f. Okay, as far as the end behavior is concerned, what's ultimately going on, even though you may have a turning point in between your ends. Okay, what happens if you have a negative coefficient? Well, it flips. Now you're doing the opposite. You have x approaching negative infinity. F of x is actually approaching positive infinity. As x approaches positive infinity, f of x approaches negative infinity. Once again, you have turning points, but what ultimately decides your end behavior is going to be the even or odd exponent and the sign of your coefficient.